welcome back. We have been discussing about fundamentals of logic design. So let's have a quick recall of what we discussed. So we discussed the three fundamental Boolean operations, which is OR, AND, NOT. So here we said it is inversion, and this is how we represented. Here we said it is and here we said it is OR, which was very similar to a plus operation, and was very similar to a multiplication operation. Not exactly multiplication and addition, I will say, but very, very closely. So we are using this notation to represent that operation. And this is bar. And we saw a few important binary relationship or Boolean logic relationship. What were they? Quickly, let's look at that. X ORed with X will give you X back. X ANDed with X gives you X back. X ORed with 1 or X gives you 1. X ORed with 0 gives you X. X ANDed with 1 gives you X. X ANDed with 0 gives you 0. And double negation of X gives you back X. Correct? And we also understood truth table. Correct? We are going to continue today's discussion based on truth table only. So what is truth table? It is the representation of all possible input combinations which are evaluated and output is calculated. And the output, I denote IP as input and OP as output. Output is evaluated. Or rather, I will say output is obtained. Just looking more complete or cleaner in terms of English. Okay. So we saw, for example, I have W, X, Z, 0, 0, 0, 1, 1, 0, 1, 1. If I write this is OR. Correct? This is the truth table of two input OR operation. Correct? It's the truth table of two input OR operation. Correct? These things we saw in the last session. Correct? So we are going to continue from there. So let's continue with the truth table and this Boolean relationships. Okay, so I will say Boolean relationships and the truth table. We are continuing. So an important property we are going to see this way. Two Boolean operations are said to be equal if they give the same output. If they give the same output for the multiply the inputs. Okay. Let us look at, or what I mean is, if two columns, two output columns of the truth table match, then the Boolean operations are, then those two Boolean operations are equal. For example, let us write it. For example, now I am going to write this. So I am going to take x, you take y. These are my inputs. Correct? So what are the possibilities? 0, 0, 0, 1, 1, 0, 1, 1. This also we noted last class, correct? I have two inputs, each capable of taking two values, each capable of taking two values, 0 or 1. So how many input possibilities are there? 2 power 2 equal to 4 input possibilities. I have listed all the 4 input possibilities, correct? 1, 2, 3, 4. All the 4 input possibilities we have listed. Okay. Now I am going to do this operation called x ORed with y. If I OR x and y, if I OR x, y, what will I get? 0 ORed with 0 gives me 0. 0 ORed with 1 gives me 1. 1 ORed with 0 gives me 1. 1 ORed with 1 gives me 1. Okay? Okay? Now, I am going to do some other operation here called x bar. X bar is what? Inversion, correct? So x is 1 here, so I will get, x is 0 here, I will get 1. X is 0 here, I will get 1. X is 1 here, I will get 0. X is 1 here, I will get 0. Okay? Now, I am going to do x bar ANDed with y. I am going to AND x bar with y. So what will I get? 0 ANDed with 1. What will give me? 0. 1 ANDed with 1 gives me 1. 0 ANDed with 0 gives me 0. 1 ANDed with 0 gives me 0. Correct? Now I am going to do one more operation here. I am going to do x. I am going to OR the x with x bar y. So this column and this column I am ORing. Look at this. This column and this column I am ORing. I want you to pay attention. 0 ORed with 0 gives me 0. 0 ORed with 1 gives me 1. Now I am going to do this ORing in a little bit smart way. I am going to OR x, correct, with x bar y. In these two cases, x is 1, and since I am going to OR, irrespective of x bar y, the result will be, yes, it is going to be 1. If you actually check also, you will get the same thing. 1 ORed with 0 gives you 1. 1 ORed with 0 gives you 1. Now, look at the beauty here. This column called x or y and this column called x ORed with x bar y, they are giving the same output for this input combination. For 0, 0, x OR y is also giving you 0, x ORed with x bar y is also giving you 0. For 0, 1, x or y is also giving you 1, x ORed with x bar y is also giving you 1. For 1, 0, x or y is giving you 1, x ORed with x bar y is also giving you 1. For input combination called 1, 1, x or y is giving you 1, x ORed with x bar y is also giving you 1. So for all the input combination, they are getting the same output, or the two. This is exactly what we told. If two output columns of the truth table match, then those two Boolean operations are equal. Based on this, what can I say? X or Y, this operation is same as x ORed with x bar y. This is a very important relationship in Boolean algebra. This is called as redundancy theorem.